Hi, I'm Pushpak. I'm one of the founders of Harden, where we are building the most advanced AI agents for security and governance. With Harden, business teams can build on company data, while IT team gets to keep control over security policies, runtime governance, integrations, and audit. And best of all, our security agents run completely inside your cloud, so your source code and sensitive data never leave your walled gardens. Let me give you a walkthrough of our product. This is the Harden dashboard, which shows every hardened app with a list of all the vulnerabilities found ranked by what will actually hurt you. And this is more than just code scanning. Our advanced AI engine catches things like internal endpoints that are reachable because of broken authentication, hard-coded API keys, prompt injection vulnerabilities, SQL injection risks, and a lot more. The homepage also shows you which of the apps have runtime enforcement enabled, but more on this a bit later. On the bottom left, I can see that the Harden BYOC runtime component is installed and is healthy. This is the component that is running in your cloud that is actually running all of Harden's scan and autofix agents. The apps page shows you all the apps that you have already hardened. To harden an app, simply click on the Harden app button. Let's give it a name like My Reimbursement Tracker app. Next, I need to add repositories that are part of this app. Harden supports GitLab and GitHub, and both the cloud and the self-hosted versions of them. You can have multiple repositories that are part of a single app. Here, let me go and pick the ones that are part of this app. The API app is a backend app. I will choose the main branch and add it to this app. Next, I will do the reimbursement web repo. I'll stick with the main branch, and this is a front-end app. I will mark it as such and add it to the app. At this point, my reimbursement tracker app has 2 associated repositories. Now let me just go and see if everything is wired up correctly. And my pre-flight checks came out to be green, so everything is wired up correctly. Now we can just run scans right from this screen. Our scanning pipeline has been kicked off. Remember that every scan is actually happening within your cloud environment, so no source code is actually leaving your cloud. We can track the progress of the different scans below. Our advanced AI scanner uses our proprietary algorithms and a custom harness to map the codebase into an exploit graph and run pentest-grade scans without actually executing the code, tracing the exact paths an attacker would take and flagging the ones that are genuinely exploitable. Our agents run on audit missions to find all exploits, only surface the ones that have been confirmed to be exploitable. We will give a few minutes for the scan to complete. And all of our scans are completed, and all of our findings are displayed here for us to review, sorted by severity. Clicking into any one of them gives me more details about the vulnerability, and I can also generate a fix. If I like the fix, I can accept it and move on to the next one. Here I can do the same, and once I'm done with all the fixes, I can simply create a single pull request with all the fixes. Now I have an audit log of the pull request that was created, and I can follow it on GitHub. The apps page does more than just show you the vulnerabilities. It also shows you all the different capabilities of the app, such as what kind of endpoints is the app using and what kind of auth are they behind. What kind of data sources is the app going to touch, and what kind of LLMs, if any, is the app going to use during its runtime. I can also see a history of all the scans that were run on this app, the fixes that are open, the version of the scanner that was used to run the scan, and a lot more. But even after this app ships, the agent inside it can take action on its own, and a hijacked or confused agent will try to do real damage. Our AI firewall product protects your apps during runtime as well. Every line here is a real-world attack, an agent dumping customer records into pastebin, or trying to send an email to an dangerous unauthorized domain, an agent trying to run unapproved tool calls, and many more. Clicking on any of these agents gives me a full trace of what transpired and what was blocked. And best of all, it can all be exported as evidence with just one click. And it really doesn't matter how the app was built. This one was built outside Harden, using a different framework altogether, running a different model, but we are enforcing just the same. Scan, fix, enforce. Every AI-built app in your own cloud. That's how you say yes to AI without owning the breach. That's Harden. Thanks everybody for watching.